Today's session. And in my today's session, I'm going to discuss a few important points. These points were not earlier discussed in our scheduled class. And it is also a wonderful thing that one of the points was actually raised by class representative of our CSE section A, Aniket. Aniket has had some doubts in the class regarding the sequence problem, and I'm going to clear this particular doubt from his mind and from everybody's mind. But before that, when in today morning, when Aniket actually WhatsApped me regarding his doubt, and I sat there to think on the issue, then suddenly something came to my mind, and I watched my earlier YouTube videos, and I saw there that the points which I discussed was all right, no problem with that. But I thought somehow that I were not pretty much clear about defining the examples related to vector space. One of the examples, mainly the example which I discussed in the introductory session of the vector space class. Okay, so that point, I'm starting with that point, and gradually I'm coming to the question raised by Aniket. And also I'm going to discuss the one relevant thing which is often used, which is mostly used in the discussion of vector space, and that is called field. Okay, so one after another, I'm coming to the details of this particular. I'm going to discuss details of these particular issues. Okay, so first of all, to start with, I must write in this manner: clarification number one. Clarification number one. Okay, maybe you have understood, I don't know. I want to make sure that you have understood properly. So I'm going to talk about something which has already been discussed in the earlier class. I discussed a problem on the set of all possible matrices, and I showed that this matrix was that set of all possible matrices of order m by n was a vector space. So first of all, I'm going to write the question here. Here the solution of this particular problem is known to you. The solution I'm not going to repeat because it is already there. The thing has already been properly discussed. But here I'm going to discuss something else. So first of all, it is extremely important for me to write the question. Okay, the question, I'm copying it from the book of Friedberg, which has already been shared with you. The problem was the set of all m by n matrices with entries from a field F is a vector space. We have already proved it. This particular example has already been proved. Okay, the proof was all right. No problem with that. And it is a vector space with respect to the matrix addition and scalar multiplication of the matrix. Okay, so that was these were the two operations which were there which were defined on the set of all possible matrices. The set was denoted by the symbol by the symbol m cross n f. Okay, and the matrix addition, if we denote this by the matrix addition, if denoted by the notation plus, and scalar multiplication if denoted by dot, then we have proved that the structure the structure m cross n f, okay, comma, matrix addition plus, and the scalar multiplication dot, this structure is a vector space, or for simplicity we sometimes say m cross n f is a vector space, We do not, when we use simply this particular statement, we are sure about the operations, because we know that when we talk about set of all possible matrices, and when we say that this is a vector space, everybody understands that obviously it is a vector. I'm talking about a structure, and some kind of operations are defined. So when we say that capital M cross n f is a vector space, obviously it is with respect to two operations. One is vector addition, which is matrix addition in this case, and the scalar multiplication, when we multiply a matrix by a scalar. Okay, so we can explicitly write it as in this manner, or sometimes we can write it as we can write it simply without mentioning about the operations. Okay, so that this particular issue has already been resolved. Okay, now the point is, and also it was given in the book, in the example, that the matrix additions were defined in the following manner: aij plus bij is equal to a plus bij, and C, capital A ij, is equal to C into capital A ij. Now the important part which has not been discussed in this example is the following. Okay, it was implied, though it was implied in my discussion, in my example, when I solved the example, it was in my mind, but I didn't explicitly define it. So I thought, after getting the question raised by the student in the morning, I thought that I need to discuss this issue first. I have to clarify this issue first of all, then I can go to the problem which was raised by the student. Okay, so let me clarify the thing. We know that two matrices can be added when their orders are same. We all know that. Okay, and we also know that when we multiply a matrix by a scalar quantity, each element gets multiplied, each element of the matrix gets multiplied. Okay, now the thing is that when we talk about the vector space, when we talk about the set V, and when we say that it is the set of all possible matrices of order m by n, which we denote by m cross n f, don't think that this particular set contains all the elements of the form, all the matrices of different order. Say it contains a 2 by 2 matrix, also it contains a 2 by 3 matrix, also it contains a 3 by 3 matrix, and so as many matrices as we can consider over here. It is not like that. Okay, it contains a matrix. Actually, this particular set m cross n, it contains a matrix of the form like this. This order of this matrix is m cross n. Again, we have another matrix of order m cross n. The element inside the matrices, the element are taken from the field. So we have all the matrices in this particular case are m cross n like this, and it goes up to infinity, all possible matrices of order m cross n. So if, for example, if we consider, say for example, if we consider the set m2 cross 2 f, then it means that it is a set containing only the 2 by 2 matrices with different elements in it. Okay, all the matrices in this particular case, in this particular set, are 2 by 2 like this. When we talk about, say, m2 by 3 matrices, say for example, these are all examples, then in this particular case the matrices are of order like this, and so on. When we talk about the matrices, say for example m3 cross 2f, then it means that we have the elements like this, and so on. Okay, so according to our calculation which we did in the first class, this is a vector space, this is a vector space, this is a vector space. Here the additive identity, is 0 0. Here the additive identity is, and here the additive identity like this, and so on, and so on. So in general, when we talk about this is a very general condition. This is a very, when we talk about this is a very general matrix. This case is a very general case. Okay, so actually we actually avoid talking about individual matrices of different order, and we talk about the general case, and therefore we say that m cross n is the matrix of all possible orders. Okay, so individually these are the vector spaces, so we consider this general case and we say that it is also, if you can show that this particular set of matrices is a vector space, then each of its siblings are also vector spaces. So when we talk about this general term, general set, then for this the additive identity becomes, of this form. M cross n. Okay, why am I saying this? Why am I saying all these things to you right now? Because you may think that probably in my earlier example I wasn't clear. I didn't say it clearly that the matrix elements are specifically of the order, the set elements are specifically of the set elements are matrices, and they are of specific order m by n. So you may think that for some, all the possible matrices, even 2 by 2 matrices is present over here, 3 by 3 matrices is present over here, 3 by 2 matrices is present over here, 3 by 3 matrices is present over here. It is not like this. Why? Suppose, let me say why it is so. Suppose your understanding is wrong. Suppose you are thinking it in this manner. Suppose you are saying that, sir, this particular set you are telling me wrong. You are telling us not the right thing. You are telling us something is not clear to us. It is saying that it is a set of all possible matrices of order m by n. So why shouldn't we consider a matrix elements of this order 2 by 2 over here, and a matrix element of this order here, and a matrix element of this order here, like this? Can't we consider together these things together in the same in this particular set? Can't we consider them? If we think like this, what is the problem? This is your question. You are actually asking me. This is the question. Can't we think in this manner? In this manner, if anyone's understanding is like this, so what will be the problem? The answer is however no. Why? Because you will not be able to find, in this case you will not be able to find a unique additive identity for each of these elements, because there is a very important theorem which says that, the theorem says that the additive identity and additive inverse of a vector space if exists are unique. There cannot be two additive identities and two inverses. So if they exist, they are unique. Okay. So therefore, if we consider this to be a vector space, its additive identity, this additive identity is unique. Okay. For this vector space, this is the unique additive identity. For this vector space, it is the unique additive identity. For this vector space with m by n elements in it, this is the unique additive identity. So somehow I thought that this particular understanding was not clarified in the previous classes, and therefore I actually decided to talk about this. Now Ayan Banerjee has written, additive identity and inverse will be different for each, then they aren't same when we consider matrices of various size, so it can't be vector space. This is what we were saying. Additive identity and inverse will be different for each, then they aren't the same when we consider matrices of various sizes, so it can't be vector space. Obviously everybody can see what Ayan Banerjee has written. Okay, so Ayan Banerjee's understanding is clear. He has understood it properly. So if I consider these elements together inside it, if your understanding is like that, then for this we have an additive identity of order 2 by 2. For this, its additive identity will be of order 3 by 2. For this, it is 2 by 3. So all the additive identities will be different, and which violates the theorem. And therefore, you cannot consider all these elements inside this particular set of matrices. So when we actually solved that this particular set of all possible matrices is vector spaces, we solved it for m by n matrices. The solution was all right. The way I solved it, it is all right, but the understanding has to be proper. So once you solve it, that means you don't have to solve, you don't have to show each of these matrices separately that these are vector spaces. I hope you have understood. This is my clarification one. So if you have understood, please write in the chat box, then I can proceed to the next clarification. Please make sure that you have understood my point, then I can go to the next clarification. Then I can start the next clarification. Okay, okay, so you are, yeah, you have understood, then it is all right. Now Aniket, the CR, he actually raised a question. He actually, when I took your class, last class, he raised the question, he wrote in the chat box, but probably my thinking was I was in a hurry, I couldn't understand what he was saying, and later he WhatsApped me. Okay, he thought about it and he WhatsApped me and he said, sir, you said this, I said this, but I'm not getting the connection between these two. So still this particular issue is haunting me, please help me. I could have replied him personally over phone, but I decided to take this class because if this problem is with Aniket, then the problem is with entire class. Okay, so that's why I have decided to talk about this issue, and that is my clarification number 2. So I'm going to write I'm going to clarify the point 2. So you write clarification number 2. For this, I have to take the pain of writing the example which is given in the book. And I will first copy the example. Okay, this example has already been solved. That is also solved example, but that has been solved in our class. But I have to write the question. When I talk about this, then this question should be in front of you. So let me copy the question from the book. And this is not question, its example is given in the feedback. It has not been solved, but just they have said that it is a vector space. So let me write it first of all. So the example was, let capital F be any field. Let capital F be any field. A sequence in F, a sequence in F is a function sigma from the positive integers into F. Okay. The sequence sigma is denoted by sigma n is equal to an for n is equal to 1, 2, dot up to infinity, or by simply writing an, or sometimes in some books sequences are written in this manner. Let capital V consists of all sequences an in F that have only a finite number of non-zero terms an. If an and bn, sequence an and sequence bn are in V and small t belonging to capital F define operations like this, define operations like this: an plus bn is equal to an plus bn, and t an is equal to t into an with these operations, with these operations, with these operations, we can write here this plus for vector addition and this dot for vector scalar multiplication. So with these operations we can, sorry, this is a simple dot and I can write it over here like this. This is the dot, this is the vector scalar multiplication, this is the scalar multiplication, and this is the multiplication between the two numbers, simple multiplication between the two numbers. With these operations we can say that the structure, this structure is sometimes also known as triplet. The triplet capital V with the operations plus and dot is a vector space, is a vector space. This problem has already been solved, so I'm not going to discuss this problem, but I'm going to discuss a very relevant issue. First of all, here also you have to understand the fact that your V, capital V, let us write capital V by simply this, V1, it may contain elements like this. Since I'm using the single bracket for writing the set, so I am going to use this notation over here, okay, triangle bracket, to make you understand a sequence. Or you can write this bracket, no problem with that. So your V1 can contain elements like this. Say we have the elements like this: A1, B1, C1, all the singleton sets, singleton set like things. So here you can apply these operations. This operation is defined over here, okay. If we also can consider a set V2 like A1, A2, or say B1, B2, or say C1, C2 like this. Here also we can define these operations, okay. We can consider V3 similar way. When we prove this result, we consider the Vn actually, which we denoted by V according to the book's notation, and it contains sequences like this, okay. It contains sequences like this. All the sequences are up to n terms. V contains infinitely many points, but all the sequences are up to n terms, okay. And I told you that the additive identity in this particular case, the additive identity in this case was like this: 0, 0, dot 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 0, so that I can write A1, A2, dot 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 AN plus 0, 0, dot 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 0, or I simply wrote in this manner for simplicity, where I wrote n belonging to capital N, and you can write n belonging to capital N, and I wrote this is equal to n belonging to capital N, or you can write it in this manner if you want to write it explicitly, sorry, A1 plus 0, A2 plus 0, AN plus 0, like this, which is equal to A1, A2, dot 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 AN, or which is equal to AN, n belonging to capital N. This is, first of all, this thing was not explicitly written in the previous class. It was not explicitly written, and so there was a problem. Probably there was a problem in the understanding. And the second important thing is that that the question was raised by the student. I am coming to that question now. He said to me that he was some sort of allergic towards this statement. The statement says have only finite number of non-zero terms n in it. Now he asked me that day also, he asked me, if you can remember, sir, the student asked, how can 000, how can you justify that 000 belongs to capital V, since all these terms are zero terms? What is the justification that it belongs to capital V? Because it is not fulfilling the condition given in the problem. And this particular issue kept me thinking, and I had to go through several other books, and there also I couldn't find the books which I had. And even in Google, when I made a surfing in the Google, the issue was not actually not the problem was not, issue was still there, the problem was not solved. I couldn't get the answer correctly. And suddenly, when I kept on thinking today morning, after reaching to the college, I suddenly saw something which was not actually initially pointed by me. It was known to me, the fact was known to me, but I was kind of a prejudiced or biased towards the thing that the books, like any foreign author books, generally there is no printing mistake. Generally in a foreign author's book there is no printing mistake, but here in this Friedberg book there is one, and which I neglected, and therefore it created the lots of troubles. The actual important point, which was actual term which created the problem, is this one. This particular word is actually created problem. This is wrong. The actual definition of this particular set is actually, it was the author was supposed to write, he meant to say that V consists of all sequences an in F that have at most small n, or you can write a finite number, at most small n number of non-zero terms an, at most small n number of non-zero terms an. So what do we mean by at most? When we say that at most one, it means actually one or less than that, one or less than one. When we talk about at least one, it means one or more than one. Probably you know this thing. So when we say that at most the sequence contains, when we say that the sequence contains at most n non-zero terms in it, that implies we can get a term like this, or 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 we can get a term like this. And this justifies that 000 belongs to V. I hope that Aniket is present and he has understood the point. And when we talk about when we talk about this sequence, when we talk about this set, then here in this particular set, if we consider this set and we want to show that it is a vector space, then the additive identity will be, let me write with a different color. If I'm talking about this set, the additive identity, just like my matrix example, this will be 0. Here the additive identity will be 0, 0. And here the additive identity will be 0, 0, 0. And here the additive identity will be 0, 0, dot, 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 0, up to n terms. Let's see what students are writing. Abhirup Roy says that aaj pura samajh mein aaya. Sir, I couldn't understand this. Can you please repeat? Oh my God, the session is going to end. I'm going to, Ashwarya, don't panic. I'm going to upload the video in the YouTube. You go through the video once again, fast forward and backward and forward and backward, and then you will understand. Because we have 1 minute 38 seconds left for this session. After that, you are going to re-enter into the session because I have to discuss something more. Now, Aniket is saying, thank you so much, sir. That means he has understood, his doubt has been clarified. Abhirup Roy is saying that aaj pura samajh mein aaya means पूरे क्लास को पहले थोड़ा थोड़ा समझ में आया था, पूरा समझ में नहीं आया था. And I was pretty much sure, and I'm very much thankful to this student, because if he didn't raise the question to me, then I probably missed this particular point. And I also have to tell the students of CSE B, I have to share this video, especially this video, with the students of CSE section B, because I'm pretty much sure the doubt is also there with their mind. So I am waiting for this video to stop, this particular session to stop automatically, so that I can rejoin once again in the new session. So let us wait for the new session.